Welcome to Simulation and Prototyping. My name is Carl Dobman. I'm the Dean of the College of Architecture and Design at Lawrence Technological University. This is Module 6, and we've had our series of weekly projects, and each one of these is a module that has discussion topics, a lecture, readings, and other things going along with it. You're seeing the tutorial for the project. We've built on a number of projects over the course of the semester. Module number 5 dealt with developable and surfaces that we could unroll. We're going to use similar types of surfaces with Module 6, but bringing in a little bit more sophistication and control. And so what we're seeing on the screen right now is a kind of simple project that will end up developing through a series of steps. And what I was looking at trying to do was control a surface so that I could have it be relatively flat, but make changes in the surface, right? Lift up this edge and have the surface get pleated as a result of that. And we can see the same thing happening on the other side, lifting up the surface and going from a relatively smooth surface to a pleated folded surface, and then back to a smooth surface again. And so I tried to think through, how would I build this? What would the workflow be? And what steps or components would we need to deploy in order to make this happen? And what I want to do is kind of walk you through the process of how I did this and do it in kind of small steps. And so build a small component, test it, make sure that works. Okay, move on to the next thing, add a bit more sophistication, see if that works. If it does, move on to the next stage. And so we're going to do that over the course of this module. And even what I'll do is I'll break the module into maybe some smaller chunks as a way to kind of share this process with you about, soon you're going to have your own project to develop. How do you go about doing that? How do you look at those steps, and how do you build your success kind of incrementally throughout this process? So let's start with what I did, which was, I think over breakfast one morning, it's like, okay, how do I map this out? How do I begin to think about it? And so what you see on the screen now are just some notes before I even started in Rhino. And what I was thinking about is that, and I'll maybe use these same terms throughout this module. L1, the length is determined by something that we'll draw in Rhino. And so this will be geometry, Rhino geometry, that we'll reference within Grasshopper. This is the kind of framework that will hold or will hang other geometry on top of this. L2 is a length that has to be longer than the first length, because imagine folding a surface and fitting it within the dimension of L1. We're then going to divide that up. We're going to divide L1 by a number of divisions. And so it's going to play out something like this that we see here, that we'll take L1, we'll divide it a certain number of times, and that'll be a variable. And then L2 is this length, which will get folded across that surface. And we'll see that we have to kind of relate those two dimensions by the number of divisions that there are. The way that this will play out then is that the height of these, and we'll start where these will be a uniform height. We're also going to look at a more sophisticated version where we can actually start to control these heights. But the basic understanding is that this height we can get with the Pythagorean theorem, because this is a right angle at the bottom, or kind of, let's say, normal to the curve, perpendicular to the curve. And so we'll call this A, B, and C, and we have to solve for B. And so we're going to work through these things and start to look at how we do that. Essentially, well, let's start with a couple of steps. The first step was trying to figure out how to make a line perpendicular or normal to a curve. And I might use line and curve interchangeably. We'll start with doing this with a straight curve, but then we'll end up doing it with a more complex NURBS curve, just as a way to make sure that we have the sophistication and versatility built in to these components as we aggregate them throughout our process. So let's start within Grasshopper, and within Rhino, I'm going to start a new file that's going to be large objects feet, and I'll start a new Grasshopper file. For these first couple of studies and kind of diagrams and tests, let's just do it in the top view. We'll keep it two-dimensional. We'll keep this pretty simple. And I'm going to start, I want to test this in a couple of ways. I'm going to make a line that's 100 feet long, just a straight orthogonal line in the X direction. And then I'm also going to, so that we have an understanding of what we're doing, I'm just going to make a NURBS curve that has enough curvature and enough change in curvature that we can test these things. So let's start with this. And the first step that we're going to do is we're going to make a series of lines that are perpendicular or normal to the surface. So let's start with a curved container. And we'll start with setting this one curve, and we'll use our straight line for that. And let's divide our curve. And divide curve is a nice tool, not only for being able to divide it, but also because it gives us some additional information that we'll end up working with here. That first diagram I showed you a second ago had 5 divisions. And so maybe I'll set this to be 1, 5, 50. Right? We want to be able to really turn this up later. We'll plug that into the count. And then we'll name this while we're here. We'll name it divisions, or D is what was referenced in that previous diagram. And so now we have those divisions, right? 1, 2, 3, 4, 5 divisions. And there's actually 6 points on there. And so let's look at how we will make vertical lines. And while it's easy enough to offset these in the Y direction right now, I want to instead make a line with the start, direction, and length. And as the start of our line is going to be those points, those division points. The direction is going to be the tangents. And the length, let's see, we'll just set this to be 1 less than. And so what we see, and you have to look really closely over at this portion of the Rhino file, is that as I increase these, we see a line coming out the end on the right. And this is because the tangents of what we're using for direction are tangent from that point and moving with the direction of the curve. And so what we want to do is take that line and rotate it around that point. And so we'll let it rotate. The geometry that we're going to rotate is our line. The angle, we need to remember to set to degrees. And I'm going to set this to 90. The last step is that I don't think we need to set the plane. Let's just use our points for there. And so now we see, we still have the red line coming out here because this is this line. We can hide that. Now we've got a series of vertical lines, 90 degrees to our first curve. So that's a nice thing to have right now. We can control how many divisions there are. And we can control the length of these. The length in the end for these will be driven by another formula as we start to deal with our folded surface. But for now, let's just see if this works for our curve. And so I'm going to set one curve and set it to our curve, to our NURBS curve. Right? It works pretty well. We can increase these, and we can also change their height. So at any point along that curve, we're getting something that's perpendicular to it. If for any reason you want to flip that, there's two ways to do it. You can change the angle from 90 to -90, or we can also set the slider here to be, let's say, -20. So this is positive and this is negative. So negative direction works, as well as 90, +90, or -90. So that looks pretty good. So we've got our first step, right? And this was one of the things for me that's like, okay, if I want to build this this pleated surface, I have to be able to come off of my curve at a specific point or node along that. And looked at it a couple of different ways. I used the perpendicular frames as an option and looked at rotating them and doing different things. In the end, this was a nice way to do that. And so why don't I just group these together? And let's call this curve normals. And so this is the kind of, the way that we kind of work through. That works. That's good. Now, why don't I copy both my curve both of my curves to the right. And this will set me up for the next stage of testing this. So that's the end of part A, this first step for module 6. Just making sure that we can get lines that come off perpendicular to either a straight line or a NURBS curve. So that's a good step. Let me know if you have any questions. You can do that to YouTube. You can also subscribe to the YouTube channel. Thanks for watching, and we'll pick up the next step with part B.